I'm Mary Hardy. In this presentation, I'm going to show you some results of research that we've been doing on cash balance pension benefit liability valuation. We've been looking at cash balance benefits from the perspective of modern financial analysis to see if that gives us any insight into the value and cost of these pension plans, which are pretty popular these days. We think that some of our results are counterintuitive, and that is why I'm going to show you this presentation with very little technical content. We're not going to give you the technical details. We're just going to show you some interesting results which we're going to discuss in due course. So here's our outline. A bit of introduction as to what we understand by cash balance and our language, a little bit of discussion about what we mean by market valuation, and then we're going to show you some results. So the cash balance pension design, it's almost the simplest possible pension design. There's a level percent of salary contribution paid into a participant account, and that account accumulates at a specified crediting interest rate, and the benefit is just the account value. It's very similar to a defined contribution plan, but there are two key differences. The first key difference is that in the defined contribution plan, the assets accumulate at whatever rate the assets earn. And so there's nothing guaranteed. In a cash balance plan, which is a defined benefit plan, the accumulation rate is specified in advance in some terms. And the other key difference is that in the cash balance pension, the accounts, the contributions, these are all notional. There may be more or less money in the plan, in the funds, than the participant accounts. Usually, it will never be the same amount, unlike the defined contribution where it's defined to be the same amount. So the account values, the contributions, these are notional. The crediting rates that are commonly used based on market interest rates, and the most common rate used is the yield on 30-year government bonds. And that's used by something in the region of 40% of the cash balance plans. And the second most common is the yield on 1-year government bonds with a margin, with an extra 1% on top of that yield. These are yields to maturity. The next most common design is a fixed rate, not a market rate at all. Fixed rates typically between 4 and 8%. We're going to illustrate that by using a 5% example. So we're going to assume we have a participant. We're valuing the liability for a single participant who retires in 20 years. We're not going to take into consideration any other exits or the cost of annuitization. We're going to look at the costs where the credited interest is based on spot rates, not on par yields, but the difference is very small. We're using an arbitrage-free model because that's what gives us a market value. And the one we're using is a Hull-White interest rate model, which is commonly used for this kind of calculation. The other thing that we need to describe is what we mean by the liability. So we're looking at an accruals basis, and we're defining the accrued benefit to be the benefit based on all of the past contributions, none of the future contributions, but allowing for the full credited interest all the way up to the exit in 20 years. And that, we think, is a natural definition of the accrued benefit and is also consistent with the use of projected unit credit in the traditional defined benefit setting. For the market valuation, we're going to calculate a market value which you can interpret as the cost of transferring the entire liability to the capital markets. And it would also be similar to the value that one would report if you're in a regime of market consistent valuation. Market valuations depend on markets. In the case of interest rate risk, it depends on the yield curve at any time. So we've done these calculations based on all the yield curves from 1998, when cash balance plans first started to become popular, up to 2013. And what we're actually going to show you in the graphs that follow are valuation factors. And the valuation factor is the market value per $1 of notional account value. So in other words, if a participant has a notional account of $100,000 and the valuation factor is 1.5, then the cost of that 100,000 account is actually 150,000. And similarly, if you have a cash balance plan where the contribution rate is 6% of salary and you have a valuation factor of 1.5, that says you actually have to pay 9% of salary in order to fund the 6% of salary benefit. So let's look at some results. The first graph here is showing you the valuation factors for a participant with 20 years to retirement at each of the dates from 1998 up to 2013. And in this case, the credited interest rate is based on the 30-year spot rate. So what do we see here? What we see here is a lot of volatility. What this graph tells you is, for example, you have a 6% notional contribution rate. In 1998, for a 6% notional contribution, you would have actually had to pay 7.2% of salary. It got a little cheaper in 2000, a little cheaper in between in around 2005. We come to 2010, and your 6% of salary is actually going to cost you around 9% of salary. So we see that the costs are actually quite different from the notional contribution rate. We also see a lot of volatility. This will be surprising to many actuaries because one of the selling points of the cash balance pension plan is the stable contribution rate. But this is not stable. This is varying from a little over 6% for a 6% plan up to 9%. That's a 50% increase. That's not stable. Now, why was the 30-year rate the most popular? It was the most popular because it's the most stable rate. The yield curve is more stable at the long end and flaps about at the short end like a fish. So it seemed logical to choose the most stable rate. But even with the most stable rate, you get unstable contributions. So is it going to be worse? Here's the results using 10-year interest rates for crediting. And in fact, you have less volatility here. Similar results, but quite a lot less volatility. Also notably, a little below the 30-year curve everywhere. Here are the results now using a 5-year rate plus 25 basis points. So 5-year spot rates plus 0.25% on top. And what we get is, again, less volatility even than the 10-year rate. So the rates now, if you have a 6% plan, are varying between about 6.5% and 7.25%. So quite a lot less variability. If we go to the 1-year rate, in typical cash balance plans, when the design is based on a crediting interest rate, 1-year government bonds, there's a margin of 100 basis points. So 1%, 1 year yield to maturity plus 1%. What you have is a higher contribution. So a 6% plan here would cost around 7.25%, but it's pretty stable. That's surprising. The 1-year rate is all over the place. 1-year rates down in 2000, 1999, 2000, were well over 5%. 1-year rates in 2013, well, we know they're a lot less than 1%. They're close to 0%. So even though we have that volatility, the contributions are actually pretty stable. And we get the same result if we use the half-year plus 1.5 basis points. Similarly stable, but higher because your margin, 1.5%, 150 basis points is higher. So what happens if you use a fixed rate? So no volatility at all in your credited interest rate. How much volatility will there be in your contribution, your actual contribution rate? So this curve that we've just added, that's the rate coming from a 5% fixed per year credited interest rate. And what you see from that is a lot of volatility. In this case down here in 1999, the valuation factor is a lot less than 1. That means it's cheaper than $1 to give $1 of benefit. But up here, 2010, it's a lot more expensive. A 6% plan up here is costing 10% of salary. So this is pretty surprising. The most stable rates give you the least stable contributions. The least stable rates give you the most stable contributions. That's interesting for designing new plans, and it needs some explaining. Other things I want to point out from this diagram. If we look at just the market-based rate, so ignore the 5% fixed rate, if we look at the market rates, they're never below 1. What does that mean? You can never offer, if you're offering a market-based interest rate crediting rate, you cannot offer that at a cost of less than $1 of cost per $1 of benefit. And that's important because a lot of people think you can. And in fact, the plans were sold in the 1990s as one of the advantages was it'll be cheaper than a defined contribution plan because $1 of benefit doesn't need to cost you a whole dollar. In fact, it could cost you a lot more. Up here, it's costing you nearly $1.50 for every $1 of benefit for a 30-year crediting rate. And the other thing I wanted to note is that if we're saying, as we are, that cash balance pensions are more expensive than you maybe thought they were, this is not because of the 2008 crisis, especially for the market-based rates. So the market-based rates are pretty expensive now, especially at the long end, but they were also expensive in the early 2000s. This is not a crisis issue. The crisis has impacted the 5% rate because that simply depends on long-term interest rates. If long-term interest rates are low, the cost of offering 5% is high. Currently they are, so the cost is high. So we have a lot of counterintuitive results. And we're going to explain why those happen, what the intuition is for part 2. Here's a summary of those conclusions. The long crediting rates give more volatile contributions than the short ones. The fixed crediting rate gives the most volatility and the most uncertainty. And none of the market-based rates ever gives a valuation factor of less than 1. You can't give something for nothing. If you're going to guarantee this market rate, then you have to pay for it. There's a short opportunity for something for nothing when you offer a fixed rate. It only happens because at that point, the entire yield curve is offering higher than the 5% fixed rate. And so what that means is that you can invest, you can offer 5% and invest for any length of time at 6%. Obviously, you can make some of that 5% up on the extra interest. And the final thing, the 2008 crisis is not the main problem here. The main problem is actually understanding the design and the financial analysis of that design. So in part 2, we're going to talk about the intuition behind these results, why they are actually predictable in the financial analysis. We'll talk about different retirement horizons, what the impact is, and how you would allow for exits and that kind of thing, and sensitivity to the assumptions. Later videos, we're also going to talk about funding plans and funding designs and different ways of defining the accrued benefit.